Okay, so let's see what is shaking here. We got a bunch of dogs in the way. Come on, dogs, get out of the way. Okay, we want to be able to solve right triangles. So we're still working with right triangles, although that's going to change in the next lesson. But for this lesson, every time I'm going to want a picture of a right triangle. And of course, every triangle does have three pieces. There are three angles and three sides. All right. Now, as we learned when we were in geometry, that if we are given three pieces of the triangle, we can usually find the other three. And if one of the three pieces happens to be a right angle, our task is greatly simplified, right? So we're going to do this one first, the right angles. If we don't have the right angle, well, come back for lesson number 3 and come back for lesson number 4. It gets trickier. But for this lesson, every single triangle will have a right angle. Okay, so I love this type of question because I gave you three pieces. I expect you to find the other three. And if you're like, I've got no idea how to begin, what should we do? Well, you got to have a picture to look at, right? And artistically, it doesn't have to be perfect, but we do need a triangle, and we need to label one of the angles as a right, right? So you can sketch a triangle, doesn't have to be perfect. Clearly label the right triangle, and we'll call that one C. The A and the B you can mix and match, right? The C has to be the right angle. Okay, now let me see. It says angle A is 36 degrees. I better add that to my picture. Angle C is 90 degrees. I already have that on there. Side B is 8.2. Okay, now side B is across from angle B. So that's what I know. All right, now it might be a little bit more clear, what we're looking at. But if I don't give you a triangle, you've got to draw a triangle. Well, I know the three angles have to add up to 180 degrees. And I've already got two of them. Remember, with a triangle, if we know two angles, we actually know all three angles because they have to add up to 180. So I should be able to quickly figure out, hey, my missing angle is 54 degrees. I can add that to my picture, and I can even put it in my answer display. Okay, now what? I need some sides. So I got to pick an angle. Let's play with the 36 degree angle. So I now know which side is opposite. I know which side is adjacent. And of course, hypotenuse, we already knew what that was. I know adjacent, and I want to figure out opposite. If I know adjacent, I want to figure out opposite. Tangent. Tangent is opposite over adjacent. So tangent of 36 degrees is A over 8.2. So 8.2 times the tangent of 36 degrees has to be A. Okay, now this is not going to happen without a calculator. All right. Notice that I have to make sure my calculator is set for degrees, not radians. And since the directions did not give me any indication of what to do, I'm just going to choose to round off the nearest tenth. So 5.95765. So I got to ask myself, was that closer to 5.9 or 6.0? It's closer to 6.0. Hey, now what? I need the hypotenuse. It's a right triangle. What can I do? If it's a right triangle and I need the hypotenuse, a squared plus b squared is c squared. Now, if I plug in 6.0 instead of using the previous answer, I might be a little bit different when we're done. right? But you can see why I did that. I said, hey, with my calculator, I can just tell it use the previous answer. And when I take the square root, I get about 10.1. If you try it with 6 instead of 5.95, etc., your answer is still going to be really close to 10.1. Again, notice the amount of work I had to show, right? Even though I'm using a calculator, I still want to show step by step on paper what the results are. And we have solved the triangle. I was given 3 pieces. I found the other 3 pieces. Okay, another question, brand new question. Again, what am I going to do? I've got to have a picture, right? I have to have some clue of what I'm looking at. So I draw a right triangle. I can put the A and the B at either acute angle, but C has to be that right angle. So I know side A is 3, right? That's opposite angle A. I know side C is 7. That's opposite angle C. That's the hypotenuse. Where should we start on this one? Well, I can find angle A. I know the opposite. I know the hypotenuse. Sine is opposite over hypotenuse. All right. So, and now notice I've got a little mix match here, right? We use theta as the generic variable quite often in trigonometry. So instead of saying, hey, the sine of x would be opposite over hypotenuse, I just say, hey, the sine of angle theta is opposite over hypotenuse. And of course, in this case, I want angle A, right? So theta is kind of like my universal variable. And now I want to actually look at angle A. That's my specific variable, my local variable. Hey, 3/7 might be the sine of A, but I actually want angle A. So I have to do arc sine or inverse sine, right? I have to do the inverse function of sine. Again, make sure my calculator is set for degrees. Tell my calculator, hey, I need to do the inverse sine of 3/7. Calculator says, oh, you're about 25 degrees. Rounding off the nearest tenth because I don't see others in the directions. So I'll just say, the nearest tenth. 25.4 degrees. And I've got one piece solved. Hey, I know the 3 angles. It must add up to 180 degrees. If I know 2 angles, I actually know all 3 angles. Right? Because I got to add up to 180. So now I've got angle B. Let me see. Oh my goodness, I'm missing side B. Hey, it's a right triangle. A squared plus B squared equals C squared. Now, usually I'd be tempted to say, hey, let's leave this in exact radical form. But since I've already used a calculator to get a decimal approximation for angle A and a decimal approximation for angle B, I might just say, nah, right? I could try simplify it to be 2√10, or I might say, nah, since I kind of did the neat little decimal approximations, I might decide to stay with decimal approximations. Okay, so today, every triangle will have a right angle. Because there's a right angle. Because it's a triangle, you can always use the fact that the 3 angles add up to 180. And then because it's a right triangle, you can also use the Pythagorean theorem, right? You can also use the a squared plus b squared equals c squared. And Because it's a right triangle, you can always use SOHCAHTOA, right? Those are the 3 tools in your math toolbox that you can use today. And of course, sometimes you have to use the inverse function. All right, so we're going to have a lovely worksheet. And it looks like, oh, we started the very first slide with dogs. And it looks like for the grand finale, we got a little puppy doing what a lot of puppies do early on. They take a lot of naps. They just kind of close their eyes and they snore away there. Just take a nice little break.